In terms of outreach in public schools, when we go and meet with middle schoolers and high schoolers, most of the questions, majority of the questions actually, often revolve around sleep and the brain. Sleep is, an absolutely essential, component of our daily lives. You've got to sleep. In fact, not sleeping will kill you. We need, differing amounts of sleep at different stages of development. And one of the fascinating things about sleep is how, if you have a toddler, if you're a parent of a toddler, if you, have a little brother or sister, they need naps, right? They need sort of regular naps. And that's kind of culturally accepted that, there's a normal, kind of circadian cycling of sleep and wake that toddlers go through. And it should be respected, because if you don't, there are consequences in terms of behavior and, also in terms of brain development. Sleep is essential. And that's true also for adolescents and young adults. So one of the wildest things, the sort of biggest disconnects between, the biology of our brains and our need, our physical need for sleep, for regular sleep, is how it is quite natural and normal for our circadian cycles to shift later, during, puberty and adolescence and into young adulthood, so that it is pretty much physically impossible for young people at those ages to actually get to bed at 8 o'clock or 9 o'clock or whatever, the expected bedtime, is, for kids that age, and then get up the next morning for often extremely early, school start times. Now with a pandemic, there are maybe some, in some ways beneficial changes in terms of you don't have to get up, as early, especially if you have a 7:15 a.m., first class. And, we've been to high schools in Clark County, for example, in Washington, where, they started at 7:15 a.m., and many students actually had to, get up and then get themselves there from long distances. It was not an easy thing at all to get up at that hour. I mean, actually, sleep researchers have suggested that, it's like asking an adult, who can easily fall asleep typically. I mean, again, there's a lot of variability too, but more easily fall asleep at 9 o'clock at night, to get up every day at 3 a.m., and go to work. That doesn't work. That's very difficult to get up. And, adolescence, there's tremendous amounts of brain development going on during that period of time too. As an infant, you arrive with 200 billion, neurons in your head. And then, by the time you're through school, you've cut that in half. So, there's a lot of rewiring and reconnecting and, developmental activity that experience is writing, basically on network connections in the brain that allow us to, perform well and, make good social decisions, anticipate, consequences, plan, ahead, and, sort of survive and thrive, right? And interfering with regular sleep like that is, to be, quite honest and direct, just purely abusive. There are sleep researchers have also suggested that, forcing teenagers to get up at, 6 a.m. to get ready for a 7:15 a.m., class start time is abusive. It's actually damaging, to brain development. Some of the benefits of sleep include improved memory, increased immune response. So if you don't want, people spreading, viruses or becoming susceptible to viral infection and things like that, well then, offering opportunities for excellent sleep is critical. More positive social interpretations the next day of events and circumstances. When you have a good, solid night's sleep, better social decision making. There are all these these behavior issues that are identified in schools, many of which start far too early in the morning for, healthy adolescent brain development. There's a famous study that was done in Seattle public schools where they shifted their start time just an hour forwards I think it's called the Sleep More in Seattle study, and they found tremendous improvements in mental health, in attendance, huge reductions in fatal accidents. Many young people have to get themselves to school, sometimes driving, and that's very dangerous if you haven't had significant sleep. And also even walking in public transit and bicycling, you could if you're not going to be fully attentive and fully awake and alert, there are greater risks to survival in those circumstances. So there were just absolutely tremendous improvements in test scores and grades and everything, simply from shifting the start time an hour forward. So I mean, it's a no-brainer. It's something that we should absolutely be doing. Other aspects then of sleep benefits include reduced anxiety and stress, healthier brain development. So public policy changes are clearly indicated from neuroscience research on the brain development and sleep. Later school start times, permanent standard time actually too. That shift back and forth is very detrimental to brain health. Major increases in accidents when we spring ahead, right? And we have to get up an hour earlier. For so many houseless youth and houseless individuals in our community, the idea that we would expect the same sort of social decisions and behaviors that you feel you could make when you were actually getting good sleep and you have a safe space to sleep and to rest your head is completely unrealistic. Housing first should be is clearly indicated. All of us need safe places to rest our heads and sleep. Reduced nighttime lighting. Blue light actually shuts off the release of a very critical hormone from a gland at the back of your brainstem called the pineal gland, a hormone called melatonin. Melatonin release occurs when light levels are dropping. So if you pick up your phone or you watch Netflix or something like that on a big screen and you get all that blue light in particular coming towards your direction, it'll shut off release of melatonin. It'll delay the onset of sleep. It'll be harder to get to sleep until later. Less income inequality, obviously. People who are stressed or anxious, like many of us are actually, have more difficulty with getting to sleep. There's more mind racing. Quite a bit of conscious mind racing before, an ability to actually drift off and go to sleep. And clearly also accessible healthcare aspects. That's a huge, concern for many of us as well. Now, in the waking brain, we have networks in the brainstem, that are quite active. There are nuclei, subcortical nuclei in the brainstem that project widely throughout the brain, and they release important neurotransmitters like dopamine and norepinephrine and serotonin and acetylcholine, neurotransmitters you've probably heard of, that modulate your level of alertness and arousal, how awake you are. So basically, they're firing at a pretty rapid clip if you're awake and you're alert and you're engaged and all these sorts of things. And then as you start to get drowsier, right, as you start to get sleepier, their firing rate drops, right? Also, when you're alert and awake, those brainstem networks are releasing all those neurotransmitters like dopamine, etc., and they're helping to coordinate activity, amongst regions of the brain, networks that are distributed across the various lobes of the brain that let you pay attention, that let you, make a decision, consider options, reflect on something, that happened earlier, plan for the future, remember things, comprehend what's being said, come up with ideas and thoughts and expression. So these distributed cortical networks are coordinated and engaged when we're looking at the waking brain. We're very much involved in sort of conscious activity then too, to a large extent. If you record electrical activity of large populations of cortical neurons, right, with how they're firing up and down, right? Their rates of firing, the aggregate firing rates can be detected by this technique called EEG, which is where you put electrodes on the surface of the scalp and you're measuring, the aggregate electrical activity of, many, 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 many brain cells all firing at once, right? And you can get very, very fast, rapid activity, recorded from the alert, kind of awake brain. The fast activity is called beta activity. Other relatively fast, recordings include alpha activity. Those are characteristic, waveforms that you see when somebody is actually awake. Now, when you're asleep, that system in the brainstem, it's sometimes called the reticular activating system. But the reticular, it means fan-like. And it's because there are the cell bodies of all these neurons that release these neurotransmitters like dopamine and norepinephrine and serotonin and acetylcholine. Their cell bodies are located in clumps. Remember, subcortical nuclei that are gray matter clumps in the brainstem. But their axons reticulate. They sort of fan out to all these different areas of the brain and release neurotransmitters in other parts of the brain. Their firing rate declines. The amount of these modulatory transmitters is reduced, and then it's harder to coordinate, networks that are distributed across, brain regions by long-range kind of axonal connections, right? It's harder to coordinate that activity to pay attention, to remember, to speak, to, reflect, to do all the things, that we do, when we're conscious and awake and engaged. There are multiple stages of sleep. It's actually quite interesting, and I've got a link here that you can explore a little further, these various stages. There are what we call 4 non-REM stages, and REM is rapid eye movement. 4 stages where your eyes are kind of, not moving back and forth rapidly, and they sort of descend from, less deep sleep, stage 1, stage 2, down to much deeper layers, what we call slow wave sleep, where the EEG tracings that you record are actually in the delta and theta range. That's much slower waveforms, often higher amplitude waves, which means many more neurons in your brain are firing more slowly, but firing together. And it's interesting because, when many, many neurons are sort of firing together kind of slowly like that, that's not much information in that activity. And really, you're in a very deep sort of sleep. And then one of the most, and then in the REM sleep, right, which is the other form. So there's 4 non-REM stages, when you're in these deep, slow wave, kinds of periods of sleep. But then the REM sleep is when you'll note, if you have a dog, you'll see, their eyes will be going back and forth, they may be kicking a little bit, etc. If you wake up a person in a REM sleep, they often report, a dream experience. There was something happening, and they were kind of this is a good question though. Is dreaming conscious, right? But they will report a story. Something was going on. They were experiencing something. They were experiencing a dream. And so REM sleep, if you record EEG, it's really quite fascinating. You can look with electrodes right above the eyes and see rapid eye movement, see very characteristic patterns of rapid eye movement that you wouldn't see when you're awake. But the other recordings, the cortical recordings from the rest of the brain, are beta and alpha activity. They look a lot like, the awake state. So it's as if it is very much like the cortex is awake and processing, information, but it's not necessarily being driven anymore by externally perceived, aspects of the actual environment. And then one more really important thing I just want to mention about sleep, particularly those deep sort of slow wave stages, the non-REM stages of sleep, is that the blood vessels that feed the brain, right? The arteries which carry oxygenated blood will actually split into smaller branches that are called arterioles, and they split into very small branches that are called capillaries. And the capillaries are wrapped by the membranes of these specialized cells in our brains called glial cells. They're a special kind of glia called the astrocyte. It's like star-like shaped. And they kind of adhere around the capillaries, so they wrap their membranes around all the little capillaries all the way through your brain. And when you go into those deep slow wave stages, the astrocytes pull back just a little bit from the capillaries. And remember, your brain and your spinal cord, your central nervous system, is encased in the meninges, and within the meninges is fluid. It's called cerebrospinal fluid. And during the day, the cerebrospinal fluid is mostly outside, and it's kind of like it's going through a series of spaces in the brain and channels, what are called aqueducts and ventricles. But it's working its way through the brain, but it's not getting to all different parts of the brain. But when you go into that slow wave sleep and the astrocyte membranes pull back from the capillaries, suddenly that cerebrospinal fluid has access along all those vascular channels, all those blood vessel channels, all the way through to all different parts of your brain, and it sort of flushes in and flushes through. And what we've learned is that it cleans out a lot of molecular debris that has built up, during the day. So when you wake up after not having very good sleep, you didn't sleep the last night, and you feel like your brain is sort of filled with crud, well, you're right. There's a lot of crud in there. And if you get a really good sleep, like where you get that deep, slow wave sleep, you've actually had pulses of cerebrospinal fluid work their way through, the cerebrum and clean out a lot of that gunk. And we're learning that, with, years and years of poor sleep, that dramatically increases your risk for a whole host of, serious diseases. In fact, every major, brain disease that's been examined, like Alzheimer's or Parkinson's, is typically preceded by about a decade of really terrible sleep. So I don't want to scare you, but I just think you should prioritize sleep. And culturally, and in terms of us as a society, we should also prioritize sleep because it will improve, public health. It will improve, school, attendance and, success and performance. It'll reduce mental health and anxiety concerns. So actually, establishing a baseline where we each have, adequate, resources and a good place and a safe space, to get a night of sleep. And that's all of us would do the most, actually, would do a tremendous amount in terms of improving our circumstances. So sleep is essential.